Okay, so we're on 3.3. We're going to talk about long division of polynomials. Let's start with something simple. Suppose I want, say, 38 divided by 7. How would I do 38 divided by 7? Well, the first thing is you need to know parts to this. First thing is this is the dividend. Okay, this right here is the divisor. Okay, so if I want 38 divided by 7, you can do it the old way, where you have 7 into 38 goes 5 times. I get 35, remainder 3. So this will equal 5 is considered what we call my quotient, okay? And then we do plus the remainder. The remainder is right here. 3 of the sevenths are left. So 3 sevenths. So up here I have my quotient. That's the quotient of 38 divided by 7, and then this is my remainder. Okay? I know this seems super basic. This is super important. Okay? We've got a dividend, we've got a divisor, we have our quotient, we have our remainder. Okay? This is super important what we do, because we're going to do the same thing with polynomials. Okay, so now we have the division algorithm. So this is the division algorithm. If p of x and d of x are polynomials, d of x is not equal to 0. Okay? Then there exists unique polynomials q of x and rx, where r of x is equal to 0, where the degree of r of x is less than the degree of d of x, such that p of x equals d of x times q of x plus rx. What the heck does all this mean? Well, this is exactly what we've been doing with the 38 divided by 7. Okay? First off, this p of x here, okay? The p of x, guys, is called the dividend again. Okay. The d of x is called the divisor. This is the quotient. And that's the remainder. So this is precisely what we had earlier, except it's in a different form. If I divide everybody here by d of x, if I divide this side by d of x and that side by d of x, note that I get p of x divided by d of x, everybody parties here, equals q of x plus r of x divided by d of x. So again, dividend divided by divisor equals quotient plus remainder. Exactly the same thing I had. So instead of having 38 equaled 7 times 5 plus 3, right? We had 38 divided by 7 equals 5 plus 3 sevenths. Imagine multiplying everything by 7. 7 here, 7 here, 7 there, and I get this. That's exactly what I'm going from here to here. Okay? One more thing on this is that we want to note that when we divided 7 into 38, it could only go 5 times, right? We can't go one more time, okay? You can't go one more time. So that's when we say the degree of r of x is less than the degree of d of x. It means we can't go one more time, okay? We want that degree to be smaller then, okay? And we'll take a look at that when we get an example. Okay, now we're going to take a look at an example of using this. Suppose I want to divide this polynomial by this polynomial. So what we're looking at is we're looking at 2x cubed minus 3x squared minus 2x divided by 2x minus 3. So one thing I want to make sure we don't do is we don't cancel things right here. Okay, we can't do that. They have to be in factored form. Even if you factor this one, it will not factor on top in such a way that it will not factor in such a way that you can cancel this factor with that one. So what we have to do is we have to do long division. Now long division means we take, just like old school long division, we take our denominator, we divide it into our numerator. Okay? Just like if we went, say, 5 into, let's say, 7,529, right? So the first thing we'd ask here is we say, how many times is 5 going to 7? 1 time, so 1 times 5 is 5, and we subtract downwards, correct? Alright, we'll do the same thing here. How many times does, there's 2 terms here, So we're going to go into two terms here. How many times does 2x minus 3 go into the 2x cubed minus 3x squared? Well, I'd want to at least get 2x cubed. So what could I multiply this by to get at least 2x cubed? Well, that would be x squared. Because if I multiply here by x squared times 2x is 2x cubed. X squared times negative 3 is negative 3x squared. Correct? And what I do downwards is I subtract. Just like here, I subtract. Make sure when you subtract the whole thing. So when I subtract the whole thing, okay, we have to distribute. This becomes plus, negative, plus. Now I add down, and I get the remainder 0. Okay? I subtract. Here, I got remainder 2. What I do? I drop down the 5 and ask myself, how many times does 5 go into 25? 5 goes into 25 5 times. So 25, subtract, it's 0. Here, instead of dropping down a number, I drop it down a term. I'll get minus 2x. 0 minus 2x, you don't need the 0. And note that we have a placeholder here. That's a plus 0. So we've got a degree 3 term, degree 2 term, degree 1 term, degree 0 term. You always want to put placeholders in. Okay, you always want to put placeholders in. So I drop down this plus 0. Okay, right? And I ask myself, how many times does 2x minus 3, what do I want to multiply by so I at least get negative 2x? Well, I can multiply by negative 1. So I multiply by negative 1. Now why did I put it here? Because it's not an x term, it's a constant. Okay, if I put a minus 1 there, minus 1 times negative 2x minus 3, so I'll have negative 2x plus 3. Okay, we're going to subtract downwards. If I subtract downwards, I change the sign from change it plus, and then minus, and I'll get negative 3 right here. So that's it. That's the degree 0 term. I'm done. Okay, so what's my answer? The answer to this quotient is going to be what I have here, x squared minus 1, just like if I finish this one, drop down the 2, and it goes 0 times, right? So then we put 0 here, 5 times 0, I get 2, 29. And then I say 5, right? 25, subtract, I get 4. So my remainder is 4. Done. So the answer to this one would have been 75, 29 divided by 5. That would have been 1505 plus 4/5. Okay? Over here, I get x squared minus 1 plus what's left, negative 3 over my divisor, 2x minus 3. Okay. So let's take a look at another one after this. Okay, another try. So we're going to put 2x squared minus x plus 2. We'll divide that into 8x to the 4th, put a placeholder, because there's no degree 3 term, 0x cubed, plus 6x squared, minus 3x, plus 1. What do I want to multiply this by? So I at least get 8x to the 4th. I'll multiply it by 4x squared. Excuse me, wrong place. I can do the x squareds with the x squareds, x squareds with x squared there. So 4x squared times this is 8x to the 4th. 4x squared times that is negative 4x cubed. 4x squared times that is positive 8x squared. Subtract downwards, subtract the whole thing. That means I have to distribute. Okay? So it makes this plus, minus. Those go away. Here I'll get 4x cubed. 6x squared minus 8x squared is negative 2x squared. Okay? Drop down the negative 3x. Then I ask myself, what do I have to multiply this by to at least get 4x cubed? I would say 2x. So put a 2x here. 2x times that is 4x cubed. 2x times that is negative 2x squared. 2x times that is 4x. Okay, subtract downwards, subtract the whole thing. If I subtract the whole thing, I got to distribute the minus sign, plus negative. Add down looks good as 0, add down looks good as 0. Add here, and I think we get negative 7x. Okay, I get negative 7x there. If I drop down, I'm going to drop down my 1 plus 1. Okay, now, here's the deal. can I multiply this by anything to get a degree less than? This is a degree 2 term. This is a degree 1 term. We want to keep going until we have less than its degree. This is degree 1. This is less than its degree, so therefore we cannot multiply this by anything here to get to this guy, so we're done. So the answer to this thing is, we get 8x to the 4th plus 6x squared minus 3x plus 1 divided by that 2x squared minus x plus 2 is equal to the 4x squared plus 2x. Good. I stopped because I put plus 0, that's fine, but you don't need plus 0. This is my remainder plus, what's my remainder? Negative 7x plus 1 divided by my 2x squared minus x plus 2. Okay?